In this packet, we will go over radical expressions. First, let's discuss square roots. Here are a few examples. This example is read as the square root of 9, which means what times itself is 9. And since 3 times 3 is 9, we know the square root of 9 is 3. More examples. Square root of x squared means what times itself gives x squared. So since x times x is x squared, the square root of x squared is x. The square root of x to the fourth is x squared. The square root of x to the sixth power is x cubed. The square root of x to the eighth power is x to the fourth. Do you notice a pattern with square roots? Yes, the pattern is when we have the square root of a variable to a power. The result is the variable to the power divided by 2. A small note, since we are looking at square roots with variables, we need to make sure our result will be positive. This is done by putting absolute values around our results when necessary. I don't need to put an absolute value around the results x squared and x to the fourth, since no matter what x is, the result will be positive. More examples. Notice this last example is the square root of a negative. But knowing square root means what times itself is the number in the radical. There is nothing we know that'll work here. This is not a real number. We can simplify this later. Now we will look at cube roots. This example is read as the cube root of 8, and this means what times itself 3 times will be 8. Since 2 times 2 times 2 is 8, we know the cube root of 8 is 2. Another example. The cube root of negative 8 is negative 2, since negative 2 times negative 2 times negative 2 is negative 8. More examples. Cube root of x cubed is x, since x times x times x is x cubed. Cube root of x to the 6 is x squared. Cube root of x to the 9th is x cubed. cube root of x12 is x to the third. Do you notice a pattern for cube roots? Yes, the pattern is when we have the cube root of a variable to a power, the result will be the variable to the power divided by 3. For this example, the cube root of x to the 36 result will be x to the 12. More examples. Now let's look at some other examples of roots. This example is read as the fourth root of x to the fourth, which means what times itself 4 times gives x to the 4. Try these. Now we will look at rational exponents. Recall the pattern with square roots. The square root of a variable to a power gives the result of the variable to the power divided by 2. And remember that we can write division as a fraction, so for this example, the square root of x, the result can be written as x to the 1/2 power, which introduces another way to write radicals as a rational exponent. Similarly, we can write other radical expressions with rational exponents. The cube root of x can be written in the exponent notation as x to the 1/3 power. Again, recall the pattern we noticed from simplifying cube roots. The result was always the variable to a power divided by 3. More examples of writing radical expressions in exponent notation. Notice in this example we are able to simplify the expression more after we write it in exponent notation. As we go from radical notation to exponent notation, we can also go from rational exponents to radical notation. Since we see that radicals can be written as exponent expressions, we need to remember exponent rules. For this example, recall the product rule for exponents, which says a product of numbers with the same base and with exponents, we can simplify the expression by adding the exponents. Similarly, recall the power rule for exponents. We can multiply the exponents when we see a power to a power. Try these.